So we have learned what a program is, but the next question is, how do we write our program? Or in other words, how do we express our idea and our intention for making that idea come to life in a programming language? That's a great question. So the simplest way to do this is to express our intention in a series of steps. So we have our program be a giant list of lines with no proper organization of any sort. Just have it be this, do that, do more of this, do more of that, do something else. Here's an example demonstrating the idea. Let's say our intention is to create an application that allows us to provide a YouTuber's username, and based on that allows us to print a full link for their YouTube channel. Here's a simple pseudocode, which is just us writing the program line by line without any specific organization as agreed. And once again, this is not a real program. This is just pseudocode for us to get the concept. So in other words, it is a fake programming language, and the point of it is to get the concept of how we write a program and how object-oriented programming evolved from that. And as you can see, I have some variables here, and I'm assigning the username, and then here I'm printing the full link on how to access their YouTube channels. Now let's go one step forward in the evolution of the program and talk about procedural programming. This is a programming paradigm which says this: instead of writing our program line by line, let's organize those common lines into procedures or functions so that if we want to use them again, we don't have to repeat ourselves. For example, in the initial example, we see that if for whatever reason the YouTube channel link changes, we would need to change it in all of the three places. Granted, in this case, it is not that difficult to do, but imagine if you had thousands of lines and changes were happening very frequently. So for example, if we changed the YouTube link to something else, then we would have to change it here, here, and here. And it's easy for this case, but if there was thousands of lines everywhere and changes were happening frequently, then we would have a problem. Bottom line is that in the field of software development and computer science, we want to simplify things. Programs are becoming more and more complex to write and even harder to maintain. So with new programming paradigms, we're trying to simplify this process, making software more scalable, maintainable, and readable, so that big teams can work together over long periods of time, regardless of the amount of code present in the code base. Now let's go ahead and rewrite the code and use procedural programming paradigm. I will go ahead and create a method called print YouTube channel. So I will say print YouTube channel. Then I will pass in YouTube username as a parameter. And then what I will do is I will simply print out. So I will use the same functionality there. But the difference is that then I can use this method 3 times or however many times I want from now on in order to print what I want. So here we go. Gary V, Grant Cardone. Boom. And here we go. See, here we don't have to repeat ourselves, and we can use a procedure in order to unify common functionality. This is much better than our original implementation. The reason is because, as I've said before, if the link changes, now in this example, we only have to change it in one place. So now it is maintainable. It's also readable because we understand what's going on based on the name of the function, as opposed to just looking at multiple lines and not understanding what it is trying to do. Or we can understand what it's trying to do, but it's going to take us a little bit more, so it's not as readable. Now let's talk about object-oriented programming. What is it? Object-oriented programming is a programming paradigm which allows us to solve problems via an object or more collection of collaborating objects. So in other words, we have objects which represent the real world, and through those objects, we describe our intention. Each object contains a behavior and or attribute, just like a real object. For example, a rock is an object that has an attribute of color and age, and behavior of degrading. Another example is a person, which has an attribute of age, name, and many others, and a behavior of walking and talking, amongst other behaviors. One other example is a YouTuber who has an attribute of username and a behavior of printing out the full YouTube channel link based on the username. Rings a bell? Exactly. This is our initial example. See what we did? We combined attributes, aka data, and the behavior together in one object, which describes our intention much more naturally since it is aligned with the real world, and how we as humans think. We think in objects, and hence object-oriented programming lets us think the way we naturally do. Procedural programming might sound a bit too cryptic since we don't think in functions. With that said, let's go ahead and rewrite this in object-oriented programming. I will make an object called YouTuber. I will go ahead and take this out. Combine these just so I have more lines. And then I will say class YouTuber, my username. Then I will say constructor, given username, my username equals given username. Then I will create a function called print full channel path. I will say print. So this is what I'm going to have here. But I'm going to use my username right here. Then I will go ahead and use this object. So I'll say var powerful GRE equals new YouTuber and then I will say powerful GRE dot print full channel path. All right. And then for the rest of the guys. So do that. Do this for Gary V. Do this for Grant Cardone. And here we go. We have a class, and then we instantiate that class right here to get an object, and each object then has a behavior. Print full channel path. Print full channel path then accesses the data that is within the instantiated object, which is for this one, and for this one. Each one gets its own variable, so it's its own container. And then when we run the behavior, the function, the behavior acts on the data that is within the object that it's in. So behavior and data are both encapsulated in one object. And this behavior, which is this guy, uses the attribute that is within the object, within the same object that it's in. All right. Now, some of the concepts might be new to you, such as constructor and a class, but I will go over the OOP basics in the next video just so you're familiar with those things before we move on. Very quickly, a constructor is just a function that lets you build the object, says these are the things I need before I can create an object for you. It's a gatekeeper. So in this case, it says I need a username before I can create an object for you. A class is a blueprint for the object. So it is the roadmap that you need to use in order to create your object. Look at it as a factory and your object things coming out of the factory. Instantiating a class just means we're using the class to create an object. So the instance of our object is then assigned to a variable, such as ones I have above. So right here, we're instantiating, and then that instantiated class gets assigned to this variable, which it basically creates an object. It creates an instance of an object from our class blueprint. We create an instance of an object like so that then gets assigned to a variable. And the variable we can name anything we want. In this case, Powerful Jerry. In this case, is Gary V. In this case, is Grant Cardone. And then that variable is the instance of our object, right? So then we can then use the behaviors, which are specific to our instance of the object. Once again, don't worry. We will be talking about all this in our later videos. Now, once again, what are the benefits here? First, we have data and behavior in one place. So if we were to pass the Grant Cardone object to any other function or decided to use it anywhere else, We don't have to worry about passing in the data with it. Once you pass it to the constructor, you create the object, then the object will have everything it needs to know how to operate itself. It is autonomous. Second thing is, it still has the benefits of not repeating itself, meaning that the code is only written once, such as the print full channel path behavior. So to recap, object-oriented programming makes it easier for us to think in terms of objects, keeps our code clean by letting us have scalable, maintainable, and readable code through packing attributes and behavior together in one object and allowing us to unify code in behaviors so we don't have to repeat ourselves. I'll see you guys in the next video.